So now let's make a simple platformer game as an example. So since at the early stage of the production, usually there won't be any animation or arts done, I usually just use a square as a replacement of the main character. So since we are making a platformer, which means that the player can only move in 4 directions. You can move forward, you can move backward, and also you can jump up or fall down. And in case of a platformer, there's also physical, you also need physics simulator since the main character will be pulled down by a downward gravity force. So in this case, let's add a rigid body. And just by simply adding the rigid body, you can see that the square will start slow, and as they move forward, it slowly speeds up. And we'll also call this player. So now we want to give it a floor so that it doesn't fall through the ground. Now let's add another object, also another square. We'll move it down and make it bigger. And we will call this floor. So Unity actually already have built-in colliding system. So when two objects have colliders, any sort of colliders, and one object have rigid body, Unity will automatically calculate so that the two objects does not fall through each other. So as you can see now, our player square already gets stopped by the floor when it falls on. So we will also change the color so that it looks a bit better. Let's make the blue since I like blue. All right. So after the basics of falling and the ground, the floor is done. Let's make the character move depending on our control. So we will give it a script. Let's call it player movement. And we will create a new script, add script. So let's open it. So we won't be needing start. Start is usually used to set, for example, some values which is needed at the very beginning of the game. But at this case, we don't really need to set anything at the very start of the game, so we can simply delete that. And let's call it, let's set up some variables. So let's first start with let's call it private bool is moving. Let's call it public float speed. And let's also name one that is private int direction. Now with these three, yes, so now we can set up the button press checking. So this is a built-in function called is get key. So when you first put it, you can see that there's actually a few. There's one called get key down. There's another one called get key, and there's a third one which is get key up. So get key will always return true as long as you're holding that key down, the key you want to check. For example, if I want to check whether space is pressed, then I say get key code space. And with this function, as long as I hold the space button down, it will always return true. Now, get key down will only return true for the first iteration when you press the space button, and afterwards it will never return true again until you released it and then pressed it again. And get key up will only return true when you push down the button and then release it. Then it will return true. Now for movement, we can simply use get key because we want it to always return. We want our movement to be continuous as long as we're holding down the button. So for here, we can set up a few things. Let's say if we press the B button, then we want is moving to be true. And we also want the direction to be in the positive direction. And then we will set up another variable, which is we will use else if. Now we will check for the opposite input, which is get key code dot A. We want it to move to the left now. Then for this one, we also want is moving to be equals to true, but now we want the direction to be in the negative direction. And if none of the buttons are pressed, then in this case we want is moving to be equal to false and the direction to be equals to 0. So after this, we will write the fixed update function. So the reason why we would like to use two different functions for the movement is that, as I said before, update and fixed update, their difference is that fixed update will always have a fixed frame rate, while updates will differ depending on how fast your computer can run. So if we were to put the movement of the codes that's related to the movement of the character in update, then if your computer, for example, runs at 240 frames per second, you will see the character running much faster than someone who is using a computer that only runs at 60 frames per second, let's say it that way. So to eliminate that, we will instead put the actual movement of the character in a fixed update, so that no matter what computer the player uses, the frame rate at which the position of the character is updated will always be the same. So here we will just say that when you write this game object, it will tell the script to take the reference of the object that it is attached to. So by saying this, I'm pretty much telling the script to take the reference of the player because this is attached to the player currently. Object equals to new plus equals to new vector 3 speed multiplied by direction 0, 0. And now we should have the basics of the player movement. Let's go back. Now when you set a certain variable as a public variable, you will have the ability to change that variable in the Unity screen. As you can see that in here I set speed as a public variable, and inside here you can see that speed showed up. So I can modify this here as 1, and this number will be passed into the script, telling the script and all the other functions that's using speed that it is 1. So if I run this and I press 8, oh, okay, that is too fast. Now let's change this down a bit. Let's go with 0.2. And that, as you can see, this is a pretty reasonable speed. And yeah, this is basic movement. Now let's also give it a jump. So rigid body already have a built-in function for a physics simulator, which means that you can also give it force. So what we can do is we can create a reference to rigid body, a reference to the rigid body. Let's just call it rigid body. Now we want to check if input dot is get key code dot space. Now we want to, whenever the player presses space, we want to give the body an upward force, so it shoots up. So rigid body dot add force. If you want to see what you have to place in the bracket of a function, you can always put one bracket and scroll through this little tab that shows up under. Inside in this tab, you can see like what they want in the bracket. So in this case, it either wants a vector 2 as into which direction the forces wanted to be, which direction you want to add the force. Or you can go with the second one, which is that the direction which you want to add the force, and also like what type of force you want to add. So I will say that new vector 2 0, since we don't want to add a force to the x direction. And let's give it a jump force. let's call this jump force, and we will also say that this force is a impulse force. Now let's go back. Oops. Now you can see that an error message showed up. So since I forgot to tell the script which rigid body which rigid body should take the reference, an error message popped up in the console. So we should tell it should be the players, and we will give it a force of 2. Now, ooh, that's too much. Let's give it a 1. Just give it 0.5, which is still too much. Let's give 0.1, which looks a lot better. Now let's also change the gravity scale to, for instance, 5, so we will pull down faster. So now we can change this to 0.5. 0.3. 0.2. So now it looks much better. But as you can see, there's a problem, which is that if I were to hold down space, the player object would shoot up. So a simple fix is that instead of using getKey, which will always return true if the button is held down, we can use a function we talked about before, which is getKeyDown, which will only return true once, and then it will not return true until the button is released and repressed again. So by simply changing that to getKeyDown, now as you can see, maybe the force is too little. Let's change this to 1 maybe. Maybe also too little. Let's change this to 5. As you can see, maybe change this to 10 and change this to 3. And as you can see, if I were to hold the button, the player will not fly through the air anymore. But of course, there's another problem that will show up. That is, if I were to spam the button, the player can still fly up, as you can see.